Welcome back, everyone. Thank you for being here. This is our re-welcome. So welcome to the Curriculum Development Summit number 2. Thank you all for being here. We have just finished a round of speed networking where we asked a few questions. Who met someone interesting? Yep. Yeah, everyone. Good. That's a good sign because everyone in here is interesting. So we're going to share some engagement norms, then I'm going to do the schedule, and then we're going to get right into it. So these are 3 guidelines that we kind of developed over time for engaging in this kind of unconference type Zoom. So first one is step up, step back. There are no designated leaders here. So you don't have to wait for permission or wait for anyone to do anything. You can step right up and share your comments and questions and everything. But at the same time, be aware of how much time and airspace you are taking up and consider stepping back to allow other people's voices to be heard. The second one is to assume positive intent. We are all learners here, and it is inevitable that someone is going to mess up or say something they didn't intend or say something that they, should be educated on. So let's assume everyone comes with positive intent and share our knowledge with each other so that we can all grow. And the last is to ask, don't struggle. If something is wrong with the Zoom, if no one joins your breakout room, if you don't know where to get resources, like don't struggle, ask immediately, because there's always going to be someone else who can help you with that and make it a more positive experience immediately. And meanwhile, there is a bit.ly that you can go to, or the Jamboard that I'm putting in the chat right now. This is our shared Jamboard where we're going to be cataloging our thoughts and questions, and it should be editable by everyone. So please feel free to manipulate it however is good for your use. So if you want to add slides, if you want to move things around, if you want to duplicate things, please feel free. This is a growing shared document. And finally, our agenda, we are exactly on time. We had a round of speed networking. After this little bit that I've just done, we're going to do remarks from the host. Then we'll have time for 6 5-minute lightning talks, 3 unconference sessions, and then we're going to end with some reflections and next steps. So if you have to leave at any time, please feel free. I know you're all busy. I will automatically readmit you if you want to come back. And I know people have lots of stuff going on, so engage how you can. And we're going to have lots of fun. All right. So without further ado, I would like to turn this over to remarks from our host. Codio is the host of this Curriculum Development Summit, and their Director of Content, Patrick Esther, has some thoughts to share with us on the topic of student perspectives on mastery-based learning practices. There you go, Patrick.
Thank you, Emily. I'm going to go ahead and pull my slides up real fast. And so Codio is a computer science education platform, and I work on the content team with them. And every so often, we like to put out some research or a survey. And in this instance, we had a survey on mastery-based learning practices. And so I want to go ahead and just share with you the results of the survey. And at the end, I'll have a link if you're interested in looking at any of the research that we've done. You can go ahead and take a look at that as well. So why mastery-based learning? So mastery-based learning is, perhaps it's something that you've heard of, but it's kind of catching on, because when you tend to think of grades and grade distribution, you've got your standard bell curve. You've got some people that are doing well on one side, you've got some students who are underperforming on the other, and then you have that big area in the middle where things are okay to good, right? But what we want to do is focus on the students who are not performing where we want them to perform. And the idea behind mastery-based learning is we take that area and that number of students and we shrink it down as much as possible. And Bloom is suggesting that over 90% of students can master a subject. So it really kind of does away with this idea of this, well, some students are going to do really poorly and that's just the way things are, and we just have to accept it and move on. They're really saying that, no, we can positively impact that number of students who are underperforming. So like I said, we conducted a survey. It was done on SurveyMonkey. If you're interested more about the demographics and, how were what were the questions that you asked, how were the questions structured, that's all in the survey. You can go ahead and take a look at that. And again, I'll provide a link. We had 193 respondents. That is a small sample size, caveats apply. Almost 63% identified as female. I was a little surprised by that. And just over a quarter of the respondents were non-STEM majors taking computing courses. Perhaps that explains why we have a higher number of female students in an area that tends to be dominated by men. 57% have taken 2 to 4 computing courses. So they're not novice learners, but they're more towards the beginner spectrum if you're looking at, mastery of computer science skills. And on the whole, these respondents had a generally positive attitude towards their computing courses. So I'm going to go through and just talk about some of these mastery-based learning practices. I'm going to go over the results, and then I'll talk about some of the challenges and what are the takeaways that we can take from this survey. So the first one is that 91% of respondents want learning objectives in their courses, and about 15% of courses don't really talk about them ever or only one time. So you get the syllabus and that's it. But in our survey, we found that there's a positive correlation between frequently discussed, and that's the key, that these learning objectives are frequently discussed with the students. And when you do that, students tend to have a more positive attitude towards the course. And doing this kind of gives an area of focus. If we say we're talking about conditionals and you just jump right into syntax, but if you say we're talking about conditionals and these are the learning objectives, you can focus the students' attention on what's important. What do you need to get out of this, right? And this idea of a positive correlation between this practice and the course itself is important. It's changing state by state, but by and large, most computing courses in the US are elective. And what we want is we want that to grow. And so we want to have our students say, I'm in Dr. Comfort's class. It's so awesome. You should take it. I'm having so much fun, right? And so you'll see in some of these practices, we're going to point out that there's a positive correlation between the practice and how the student feels about the course. The next practice is grade alignment. We talked about this idea. We've got these clear learning objectives that students have, and now they want there to be a clear delineation between what it is you're supposed to know and how we are grading you, right? And 92% of the respondents said, we want this. We think it will improve our experience. Yet only 50% of the respondents said, all of my courses do this. The last thing you want when you're being evaluated is like, oh, there's a surprise. I didn't expect this. We spent all this time talking about this and I'm shown something else, right? Like that's not a fun experience. And so we want to make sure that we're not doing that to the students. If you were to give me a numerical grade for your course, I could tell you if I'm passing or if I'm failing. But if I say I'm earning an 82, what does that say about mastery? Am I mastering your course? Am I mastering this content? Like the question is, I don't really know. Like I can't tell, right? Because we don't tend to look at grades and grading in that way. 93% of the respondents said they want that feedback. They want to know, okay, I'm getting this grade in your course, but what does that tell me about? Am I mastering the content, right? And unfortunately, only 36% of the respondents said they received this feedback. And next up is rubrics. 87% of respondents said they want detailed rubrics, and that would improve their learning experience. However, about 17% of courses don't really talk about rubrics at all, kind of like, those learning objectives. And this makes sense, right? Rubrics are there to give you clear expectations of what it is you're supposed to be doing when you turn in this work. And they want that, right? And they're not getting it. So all of these practices up until now have basically been about improving communication between you, the instructor, and your students, right? We want to know what is important, what are our expectations of you doing the work, how do the learning objectives relate to what we're giving you in terms of evaluation, and then how are you doing in terms of mastery, right? All you're really doing is just improving communication with the student. So those are all those learning practices up until now. The next few learning practice or mastery-based learning practices are going to focus more on the practical side. What are students doing in the course itself? So we'll see here that 86% of respondents want opportunities to practice their skills with feedback. And that's the key thing here is they want that feedback before a graded assignment, right? Unfortunately, only 40% of the respondents said all of their computing courses allowed for them to have this kind of practice. And again, we're seeing a positive correlation between practice with feedback and the course attitude. Right. And so this is something that they want to do instead of just, acquiring knowledge and then being graded on it. They want to kind of put it into practice first. But they want that the key thing here is that feedback. If I'm not meeting your expectations, how and what ways? And then you can go back and reevaluate your work and kind of, fix those shortcomings. And in a very similar way, we're seeing 92% of respondents, they want to submit their work multiple times. And again, they want that feedback. right? Instead of saying you didn't do it right, the answer is like, but why? But how? And with multiple attempts, they can go back and work on their, say, code base for you. About 70% of the respondents said they had multiple submissions in at least one course. I was a little surprised at that number. I kind of expected it to be lower. But I think this is one of those really important key aspects of mastery-based learning. Like the work that I do, I don't just do it once and then it's ready to go, right? It's an iterative process where I'm proofreading my own work. I'm having other people look at my work. It's going through multiple revisions. Even when it's code that I'm writing, it's the same thing, right? I forget about edge cases. I got syntax errors. The way that I work, right? It's not one and done. It's an evolution. And students are saying, we want that same work experience. And that seems fair. Flexible deadlines. 79% of respondents would like flexible deadlines, and 73% said some of the courses actually had flexible deadlines. And again, there's a positive correlation. I will say that when I was an instructor, I always had flexible deadlines, but the flexible deadlines revolved around me and not the students. I always had a course because of something, you know, you've got an assembly, you've got picture day, you've got standardized tests. There's some reason where you expect to have class you expected. So I have to reevaluate, okay, what's my timeline? When are we going to do this? Do they need a little bit of extra time? Or if I don't give them extra time, are they going to give me their best quality work? Right. So I would always thought about myself and what I needed as an instructor, but I never really thought about what the student needs or what they want. And we're seeing here that, you know, they are wanting these flexible deadlines. Okay, this is probably the linchpin of mastery-based learning, right? This idea of prerequisite assignments. That is, I'm not going to go on to the next assignment until I've demonstrated mastery of the current one. So it makes no sense if I haven't mastered conditionals to go on to for loops where I need a conditional to terminate the loop at the appropriate time. So I've got to show mastery of conditionals, then I can move on to the next one. So 78% of respondents said they would like prerequisite assignments, and 93% said they had at least one prerequisite assignment. Again, this was pretty surprising to me. I didn't expect it to be that high. And again, we see a positive correlation between prerequisite assignments and course attitude. So what we've seen here, we've broken down this mastery-based learning into these separate practices. The students have, in some form or fashion, experience with these practices. It's not uniform. Maybe they get it in all their classes, maybe they get it in one, maybe don't get it in any, right? But in every instance of these things, we're seeing this is what the student wants and what they're getting is below. Now, the size of that gap varies based upon these practices. But this is what we're seeing here, right? That we have mastery-based learning, we break it down into these practices, they're seeing it and they want more. So you might be thinking, okay, so mastery-based learning, I should adopt it. Well, there are some very real challenges to mastery-based learning. And first and foremost is resources. And by that, I mean your time and effort. Can you imagine if you're going to have practice problems and every graded assignment has multiple submissions with feedback and you're going to do this all manually? Like, how are you going to regain your sanity in doing that? I mean, you have so many things that press up on your time as a teacher, right? Just adding to this, and then hopefully your class sizes grow and more people are taking computer science, right? Because it's just, whether it's policy, whether it's just growing interest on your campus, right? How do you make that work? It's really difficult. Now, you can throw money at this problem, and maybe that will help in some ways, but it's not like our schools have tons of money lying around, right? And so the instructor has very real obstacles to adopting mastery-based learning. And we also see some obstacles on the student side. One of them is procrastination. If we have flexible deadlines, do I really need to start my computer science project right now? Maybe I could do something else with my time I enjoy a little bit more, right? That can lead to procrastination. Same thing with motivation. If there are a bunch of practice problems for me to do with feedback before a graded assignment, am I going to put in the time and effort? Like, what if I do all this work? Like, it doesn't change my grade, does it? Right? So why do it? Now, not all students have these problems, but they are problems that instructors and students face when it comes to mastery-based learning. So what are the takeaways from here? Like, what do we take from all this? I think it's first and foremost important to remember that students want to see these practices in their courses. And the students that were surveyed, they were in university. And this is a K-12 summit, but I can't see K-12 students saying, I don't want to know what the learning objectives are. I don't want clear expectations for what I'm supposed to do. I don't want feedback. I don't want flexible deadlines. The students are different, yes, but what they need and want, there's going to be significant overlap when it comes to these mastery-based learning practices. And it's also important to remember that these mastery-based learning practices are beneficial to students. Now, the survey is not out to tell you that if you adopt these practices, grades will go up by X%. But like I said, we're clearing the communication, right? There's no more unpleasant surprises. Students know what's important, what's expected of them, what they got wrong, right? All of these things are beneficial to the student. And I would argue there's an element of fairness in there as well. A couple of years ago, we did another survey. This was on pedagogical practices in the classroom, but from the instructor perspective. They said the biggest motivating factor to adopt a new pedagogical practice is that it will help student comprehension. I can go back and look at all of these mastery-based learning practices and say, I could see how that would help with student comprehension, right? And that same survey about pedagogical practices, instructors says they would not, or they were afraid to adopt a new pedagogical practice if they think the students wouldn't like it. And again, if we look at all these pedagogical practices for mastery-based learning, the least popular one was 78%. So an overwhelming number of students want to see these things. So they want to see these changes. We know they're beneficial for the students, and we know that this benefit that students get is a motivating factor for instructors to adopt new pedagogical practices. But as stated on the previous page, there are very real obstacles to this. So how do we kind of reconcile this? Well, focus on the practices, not mastery-based learning as a whole. Can you frequently discuss learning objectives in your course? Maybe that's something you already do, but if it's something that you have and you don't do it frequently, maybe you can start doing that. Can you have detailed rubrics? And one of the things that's in this paper or in our survey is that we reference a paper and a book that talk about making rubrics, right? And the long and short of it is basically good rubrics don't have to be overly complex. They don't have to be incredibly time consuming. And so, increasing the quality of your rubrics could be something that you do. Same thing with saying we're having clear delineation between learning objectives and what we grade, right? Talking to the students about this is how you're doing in my course, and this is what it means towards mastery. These are all things that you can do that really don't run into those obstacles that we talked about earlier. So focus on those practices that you can easily adopt to your course, and don't worry about if I get everything from mastery-based learning. And the last thing that I want to talk about, and this might seem a little bit kind of out of left field, but take advantage of auto graders. When we think about software, right, this idea of, does this code base do what I want it to do? If it does not, what are the ways that it falls short? And how do I get this information back to the people that can rectify this problem? That's almost what you see here when we talk about students want practice problems with feedback or multiple attempts. It's very, very similar. You take the student work, you evaluate the student work, either it meets your expectations or it doesn't, and in the ways that it doesn't, you give back to the students so they can iterate upon it again. I'm very skeptical when people say, oh, I'm going to have a computer grade an essay that a student wrote. I don't know how I feel about that, but honest knee-jerk reaction is that the best way to do it? But we have a long history and we have very robust tools where we can have a computer look at code that humans write and evaluate whether it's meeting our expectations or not. And so the people that work on the quality assurance teams for software companies, they have these same kinds of problems and constraints. How do we get this information? How do we evaluate it? How do we do it all in a finite amount of time? And because they have these, testing suites and frameworks, we should be leveraging them. If we want to give feedback to student, actionable feedback, timely feedback, and we want to allow, the end goal is to allow multiple submissions. How do we do that? Like, you're not going to get TAs like a university. You're not going to be able to clone yourself, right? You're not going to be able to just teach one section of one course. There's only so many hours in a day. And so we should lean heavily on these things. And if you've never played with testing frameworks before, you should really start taking a look. They're well documented. There are tons of videos on YouTube. If you're somebody like me, you just want like visual way of learning stuff and just beginner focused. And even play around with writing your own scripts, right? If you have students that are supposed to use iteration in a problem and you say, you got to use a while loop, but not a for loop, play around with, can you write a little Python script that says, oh, I found the while loop in here, and you can give them feedback. You say, oh, I found a for loop, and what kind of feedback would I give the student? So these tools are out there, they're well used, they're well documented. And if this is something that you're interested in, we should be making use of them because we can't do it all on our own. So that's what I wanted to talk about. If you're interested in all about any of the research from this survey or any of the other research that I've mentioned, you can go to codio.com/research. You can take a look at some of the surveys we've done. We've got some case studies. We've had posters presented at CSEdDev2. That's like a big computer science education conference, but it's aimed towards the university level, but there are K-12 people who go there. And they do talk about K-12 education as well. So go ahead and take a look. All that stuff is freely available. You don't have to do anything. And it's not an ad for Codio. Like, so don't think if you read this, you're just like, we're going to try to talk you into giving money to Codio. That's really not the case. We're trying to give back and just share with you some information that we found. So thank you for your time and enjoy the rest of the summit. I appreciate it. Thanks.
Thank you so much, Patrick. Let's have a round of applause for Patrick. Moving straight along in this very short unconference today, we have a series of lightning talks that are coming up. So we have 6 people who are going to talk for 5 minutes or under. That is the challenge. We're trying to go for under. And I'm going to introduce each person very briefly. It is up to you to say your context and how you want people to address you and everything. So I'm going to start right off with our rock star, Abigail Joseph. You go ahead and take it away, Abigail.
All right. Hello, everyone. My name is Dr. Abigail Joseph. I currently work at the Oracle Education Foundation doing project-based computer science experiences for high schoolers. I'm going to talk about inspiring teachers to become designers of their own lessons. So the other day I was giving a talk through CSTA, a professional learning series on integrating computer science into different disciplines. And I asked the participants, well, why are you here? Why do you want to integrate CS? And I got an outstanding number of different answers. From I would like to teach the basics of AI and data science to teachers so that they can see how all these ideas can be integrated, to student choice is a great way to increase participation within the class so that students will see these are transferable skills and connected to other parts of their school life, providing a framework to support my non-CS teachers as they teach CS due to a state mandate. And that a lot of teachers I work with are afraid of the computer and the word science, and that it can be overwhelming for a lot of folks. So that led me, and I think a participant actually in the training said, well, one size does not fit all. So one curriculum pathway does not fit all. And so what I want you to think about today is how might we approach curriculum design from a design standpoint. So enter design thinking for curriculum design. And how can we do that? Well, we can do that by thinking about incorporating the design framework into the curriculum that we offer teachers so that they can start thinking about how to make the curriculum work for them in their context and what they're trying to achieve. And mostly what I, in the training, wanted to get the teachers to understand was for them to think about who their audience is. For some of them, it's that skeptical teacher, their colleague who's like, computer science, I don't want anything to do with that. For some of them, it was about, making computer science more culturally relevant to their students in their classroom. For some of them, it was about shedding new opportunities and light on to their students around what computer science is. And designing their curriculum and lessons from a standpoint of the problem statement that is germane to them, so that they could come up with curriculum solutions that really worked in their classroom and their class context. So the design thinking framework paired with thinking about design thinking mindsets that teachers are going to learn as they're doing this process, developing their creative confidence, having a bias towards action, developing more curiosity, optimism, collaboration, learning from framework failure is going to empower them to actually feel more empowered to teach computer science. And when I say that, I'm thinking a lot about the lower grade levels, K through 8, where teachers are trying to integrate computer science, but aren't necessarily have computer science backgrounds themselves. And so in the end, give you this quote by David Kelly, the founder of IDEO, a design firm. The main tenet of design thinking is empathy for the people you're trying to design for. Those are the teachers designing for their students, you designing for teachers. And leadership is exactly the same thing, building empathy for the people you're entrusted to help. So With that, I implore you to think about how you can empower teachers to be the designers of their lessons and not just create one-size-fits-all curriculum. Yeah, thank you.
Wonderful. Round of applause for Abigail. Thank you, Dr. Joseph. Always wonderful to have you, and a very good example of a lightning talk in under 5 minutes. I'm going to zoom us right along. We have Rudy Escobar here from Stanislaus County. So Rudy, take it away.
Good morning, everybody. My name is Rudy Escobar. I'm a STEM and Computer Science Coordinator of Stanislaus County Office of Ed. That's a hard act to follow by Dr. Joseph. I don't even know how to get that one. I should have done that before her. But today, I do not have slides prepared for this, but I do want to bring in something that that has been coming along for us. I actually support 25 districts in our county, and we are in a region that is a little bit difficult to incorporate computer science. And I really like what Dr. Joseph said about her part, because really it connects to some of the issues that we're having. So my talk is really about what schools need from CS curriculum. So the first thing that we think about when we address how do we address curriculum, what our districts are asking for, they're asking for a project-based approach. And when I think about a project-based approach, they're thinking about something that connects to the real-world experience of their own students. So when we think about the Valley, for example, the Valley is something that we need, something that is connecting to either agriculture, something that's connecting to automation, or things that are happening around their world. The other thing that is happening that is needed in the curriculum that our districts are asking is about having integration. Now, the interesting thing of the word integration, for me, it really means to be convergent. And what do I mean by convergence? Convergence really is something that is in an integrated approach, but not just as fitting it in, or something that is just you supplement computer science into the curriculum, but it's something that is really connected to the experiences that students are having with the other subjects, which is also a real world approach. The third thing that is important that is being asked about CS curriculum is really about the discourse. Have a lot of opportunities for students to have discourse in the classroom about what they're learning in computer science and with the other subjects as well. It's something that then they have the opportunity to talk, discuss, and then reflect upon what's happening in their learning over time. And then lastly, the last piece that is important to have in the curriculum, and I know that Patrick also mentioned it as well, is that the support of strategies that allow to give student feedback. It is extremely important that not only are students reflecting and students are having the opportunity to discuss, but they're also giving the opportunity to address the feedback and then receive from that feedback and being able to adjust according to what the feedback they're giving. So I think I made it right on the time. So thank you for your time.
Awesome. Thank you, Rudy. Round of applause for Rudy. Wonderful to hear from you. Our next talk is from Ruta. There we go.
Hello, everyone. My name is Ruta. Today, I would like to talk about on the topic of thoughtful computer science curriculum that sparks student creativity. Before that, a little bit information about myself. My name is Ruta. I identify with she, her, hers pronouns. I wear multiple hats. Two of them are being a curriculum designer at Teachers Lead Tech and also learning designer and adjunct faculty at the Interactive Media Arts program at NYU. Today, I will mainly be wearing the hat of being a curriculum designer at Teachers Lead Tech. Teachers Lead Tech is a educational technology startup based in Lithuania, where we work with K-5 teachers to help them start teaching computer science. We work with kids 6 to 12 years old and teachers for roughly the last 8 years, and we just started working with teachers in the US in this spring. We provide teachers with creative computer science curriculum along with the year-round micro professional development, as well as step-by-step learning guides for our students to allow for more self-directed learning. Today, I would like to focus on our pedagogical approach, what we do when creating the curriculum, and share some of the work I've been doing. So mainly, This understand, practice, and create approach was born totally from doing and learning from teacher feedback, by them working in the classroom and sharing their experiences when working with children. And the goal of this pedagogical approach is to allow both teachers and students to create step-by-step, have a soft start into computer science, especially if they haven't done that in the past, and also not to overwhelm them in the process while learning computer science, and actually also learn computer science. So here in the image, you can see the overview of one of the courses that I have designed. It's a Scratch course that has 5 topics, and each of these topics have those 3 sections: understand, practice, and create. And here's one topic in more detail. In this topic, we introduce the concept of motion and also motion commands in Scratch. And again, we do that through understand, practice, and create sections, which I want to go one by one. First one is understand section, where we introduce the concept. In this case, we introduce the concept of motion and also show its context, show the bigger picture in the context of CS as a whole. So in the image, you can see a text-based instructions for the teachers that they can use to introduce this concept in the classroom to their students. Once they learn the concept, they can go to the second section, which is practice, which is a guided exercise to get a even better understanding of the learned concept. So in the images, you can see on the left side, you can see the instructions of the exercise that we give to the teachers. So in this case, they have to create a Scratch program that recreates the animation in the image. And on the right side, you can see the screenshot of the Scratch project with single Scratch code blocks that students have to move around to recreate the animation itself. So once they learn the concept and they practice the concept, they go into the second, the most important section, which is create. During this section, both teachers and students can create their projects from scratch using the skills that they just learned. So in this example, it's a project of them drawing the first geometric shapes. So here it's the possible integration with the math subject. Teachers get text written instructions and video tutorial to teach children. And here's also the example of the final Scratch project that they create. What I showed so far is everything that teachers see, but we also want to face the students. So not only teachers teach the students, but we also want to help to assist the teachers in the classroom. So each lesson has the step-by-step learning guide that students get that takes them through the project. So in this sense, students experience our pedagogical approach through creating the project themselves. And I think I'm out of time. Again, my name is Ruta. Here's my email and the Teachers Lead Tech website if you would like to learn more about my work.
Great. Thank you so much, Ruta. Round of applause for Ruta. Thank you. Our next lightning talk is going to be from Scott Moss from LA County, who's going to talk to us about critical algorithmic literacy. Take it away, Scott.
Thank you. Hello, I am Scott Moss, and I'm a technology coordinator at the Los Angeles County Office of Education and also a doctoral candidate at UCLA. So what I'm sharing with you today, hopefully soon, is my yet to be completed research on what's called critical algorithmic literacy. And this was a case study in a 3rd and 4th grade classroom. So I'm just going to start with a definition of kind of what I'm talking about here. So it's really, I think of critical algorithmic literacy as a synthesis between media literacy and computer science. Excuse me. Provide students with the skills they can use to understand, interrogate, and critique algorithmic systems. Okay, so in my research, I found this model by Yasmin Kafai and her colleagues, which I find to be really useful as different ways of framing computer science education. And these placements on this Venn diagram of the different organizations are not, they're just very kind of, I don't know these organizations well enough to evaluate them, but just to kind of give you an idea of the way I'm thinking about this. So the cognitive framing is focused on, the concepts of computer programming, thinking about maybe future jobs and those kinds of things. The situated frame is context, and the critical places algorithms in kind of a social context focused on social justice issues. And of course, these all overlap. So because I'm working with 3rd and 4th graders and we had very limited time in this case study, we did not get into the cognitive as much as I even wanted to. So these actually, the slides you're about to see for the rest of this are slides that the students, the 3rd and 4th graders saw. So this is a media lit activity called Gender Remixer, where you have ads targeting boys, ads targeting girl, and you could have, let's say, the video for a G.I. Joe ad while listening to the audio of a Barbie ad, and vice versa. So kids get a feeling for gender bias in media here. And then we, these are 3rd and 4th graders, so we introduce them to the concept of algorithms. This is borrowed from a project at MIT, a way of, you've probably seen something like this in your studies, and I'll go through that quickly. We also looked at teaching kids about training data using, in this case, we use Google Quick Draw, which I assume a lot of you know, to help students understand how training data works. And in this case, how training incomplete or biased training data can cause biased outputs and biased results. I never started my timer. And we did lots of kinds of activities where they would have hands-on experiences with potential algorithmic bias, doing Google image searches for things like computer programmer or CEO, and seeing about algorithmic bias this way. I hope you're all familiar with the work of Joy Buolamwini with her documentary Coded Bias and her paper called Gender Shades that showed bias in facial recognition algorithms and their inability to recognize darker skinned people. I'm going fast here. And we are, and we looked at the consequences, and this was tough for 3rd and 4th graders because a lot of these consequences in the real world do not connect to their experiences, things like policing and sentencing, things like applying for college or credit, and these kinds of the consequences of algorithmic bias was definitely a challenge with 3rd and 4th graders. I wanted to do more of this kind of thing, of the interaction with computer science. And here was an activity we just showed, but students really didn't get the time to do it. And here is an extremely simple recommendation engine, right? Where it says, do you like princess movies? And if you say yes, you get Cinderella, and that's it. And if you say anything else, it says, I got nothing. So the idea behind this is that students would see, well, this is very limited. How could we make it better? And then maybe start talking about things like databases, and then maybe even talking about AI and training data, and getting that kind of behind the scenes as you would in a kind of more traditional media literacy lessons. This little activity, really, I like this one to kind of demonstrate what critical algorithmic literacy is about. This is the scenario of, okay, you're starting a new planet and you only want good people to come in and keep the bad people out. So if you look at this code, if you have a criminal record, then you're out. Well, this is a good discussion point. What would this work? Would this keep bad people out and only let good people in? Oh, I guess that does work. Okay, so anyway, so that would spur some really good discussions. And the final project for these kids was to make an app that helps people and hopefully identify possible biases in their apps that they design. And some of the kids were able to do that and know that, okay, I'm making an animal translator, so we have to record every possible animal sound. And this kid acknowledged the difficulty of that, which shows, yeah, you do need massive amounts of data for AI and those kinds of things. So, the lessons, if we would have had more time for planning, more time for the actual lessons, I think we would have gotten more out of it. But once I write up my findings and discussion, I'll let you know. So thank you.
Wonderful. Thank you so much, Scott. Round of applause for Scott. Thank you for sharing your research, even pre-publication. It's great to get a preview. And we will be looking at that, I'm sure, when it comes out at the Computer Science Education Discussion Group with CSEd Research. So I hope to see you all there. Our next presenter here is going to be Mohammed, who is joining us from Harvard University. Thank you very much, Mohammed. Take it away.
Hello, everyone. My name is Mohammed Haggag. I'm a freshman from Harvard University, hopefully majoring in computer science and education. My passion for computer science education started as a teenager in high school, particularly in the 10th grade when I got my first chance to code. However, I could not divert my attention that amongst many of my peers, I was the only one who got to do this, while they unfortunately didn't. And from here, my journey with computer science education and advocacy kind of started as a young person. And for the following years of high school, I've been teaching introductory computer science concepts and helping other computer science advocates advocate for computer science in their community. And today, from my journey, I bring you 4 tips to help your students and other young people in your community contribute to the push for computer science, especially in places where knowledge about the subject is kind of obscure. So tip number 1, and I believe Emily is sharing the slideshow, or if you guys can go to the link in the chat, you'll find it. So tip number 1 is making it personal. For many international communities, so I am from Egypt and not from the US, and even for some marginalized communities in the United States, there might not be a clear incentive to why you should learn computer science. A lot of my students found it hard to believe that computer science is highly rewarding, like financially, or that they have a future like those big names in tech, like Mark Zuckerberg or Bill Gates, simply because these are not common examples or experiences in their community. Instead, teachers should focus on core values of computer science, like self-expression, empowerment, and belonging to a wider community. Students might find this easier to relate to, and those values might show as more universal. Tip number 2 is teaching to learn. A lot of advocates or new teachers might not have experience teaching before. Even if they're experienced programmers, they might not be accustomed to speaking in public or answering questions or helping troubleshoot issues that student might face with software. As a trainer, you might be inclined to anticipate every issue your advocates might encounter and try to make a protocol to counter it. But what I discovered is that teaching is a very individual process, and trying to create scaffolding around every possible scenario slows you down and overwhelms your trainees. Rather than instructions, do experiences. Let them try and figure out for themselves what is the teaching style that is more appropriate for them. And going on from that, I also like to add another tip, which is scaffolding, but the right way. So it's good to let instructors be independent, but also be careful to not leave them stuck in a rut. New teachers also have tendencies to reinvent the wheel and do the most, which can leave them also being very overwhelmed. Make sure that you're closely following with your fellow teachers' journey and give them a sense of safety and help them get unstuck. It's also important not to micromanage. So a good way to find balance between scaffolding and micromanaging is asking a lot of questions. Help your trainees and new advocates by asking them hard questions that they can't ask for themselves. Like, what do you think is not making your students engaged? How can we change that? So those kind of questions are always very useful to help them answer their own questions, but just getting the conversation going. Tip number 4 and the final tip is content. Relatable content is key to getting students interested in anything that you're teaching. However, it's very idealistic to think that all teachers have the time, effort, or resources to create tailored content to their students' demographic. It's totally okay and perfectly fine for any teacher to use content that they found online while crediting them, of course. But training the teacher to engage the students and choose content that aligns with their interest and skill level is the important skill here. It's not enough to filter tutorials on hours of code using grade levels. Encourage teachers to actually ask questions like to their students, like asking them what they want to make, what their hobbies are, how much time they have for the lesson, and have they experienced with coding before. All of that input can inform your decisions about content. Additionally, you should also know your content that you're teaching inside out. Before administering a tutorial, use your better judgment to make sure it's culturally, linguistically, socially relevant, and accessible to the variety of learners in the classroom. And before I leave you, I have compiled these 4 tips in easy mnemonic statements. So do values, not example. Teach your kids about how computer science can benefit them in their lives and focus less on economic and um, arguments that relate to specific people. Second is do experiences, not structures. help your teachers and new advocates by letting them actually teach. And third is do questions, not answers. When teachers are getting stuck, they don't know how to ask the right questions. So help them with that, ask them the right questions and help them get to the right answers. Finally, is do intentional, not commercial. Be very wise about the content you choose to introduce to your classrooms and try to account for everybody's perspectives and the diversity of everybody that is learning. Finally, I want to thank you all so much for your time. Feel free to reach out with questions through the chat or in my email, which I'll also leave there, and enjoy the rest of your day.
Thank you so much, Mohammed. Yay, round of applause. Wonderful all the time to have a youth perspective, and you have done so much already with your limited time. It is great to hear your takeaways. I love that succinct do's and don'ts. I totally screenshotted that. Okay, our final talk is from Perry Schenk of Code VA. So take it away, Perry.
Hi, everybody. My name is Perry Schenk, and I work as Code VA's curriculum director. Code VA is a nonprofit in the state of Virginia that serves for all K-12 teachers and students in the state of Virginia to impart CS learning opportunities and to create experiences where students can really engage deeply with content in CS. So the state of Virginia has had mandated standards for K-12 education since 2017. These standards on a K-8 perspective are focused on integration. And so that's what I'm focused on with this flash talk today is about intentional computer science integration. And the methodology that we use is highly steeped in the backward design principles, if you're familiar with that. So I wanted to share a little bit about what we've learned in the last couple of years and where we're moving and what we're experiencing. Really, the whole thing is kind of a petri dish as you go through it, trying to learn how teachers respond to what you create as professional development, how they create things that they use, and what feedback that they give about the process that they use. We find that a process like this is very beneficial for teachers because they're exploring first of all, brand new content, which is computer science content. And then for some of them, even backward design is something that they need some brush up on or some experience with in order to create something that's really profound and well aligned for their students. The idea of backward design, for those of you who maybe need some of that brushing up on your own, is that you move forward with the idea of where you're headed. Not at all too unfamiliar concept, but the idea that you need to know what your endpoint is specifically in order to backward design into a lesson so that you move students in the right direction along the correct way to get there. So one of the things that we found is that the word intentional really means a lot in this context. So it's really easy to do computer science integration by bringing in some sort of tool or activity. But if it's not intentional, you're not necessarily connecting to the learning objectives that are state mandated in Virginia. And you may not be actually doing a lot of the assessment and the thinking of like, well, what did my students learn by the time we get to the end of the learning experience? So intentional in our mind means that it's something that's very specific. We're looking at the learning that has happened within the context of the CS learning throughout the entire learning experience. So what I wanted to share with you in this idea is really this problem statement that we have, which is that many teachers try to jump directly into CS integration without actually declaring those specific things that they would like to do. And it ends up just creating this kind of like superficial exploration, or it's more heavily weighted on the content that they're integrating with instead of the CS content. And in the end, students aren't necessarily more knowledgeable within the context of CS. Like they don't think of it as like, I have learned computer science skills. We find that intentional kind of like speaking about computer science is a part of it's one of the puzzles of the pieces of the puzzle. So this flow map that that I have here for you is a way to conceptualize the way to use backward design to approach integration. At some point, you have to decide, well, am I teaching a core objective? And I use core very loosely, like it could be any other adjacent curricula. Or am I starting with choosing a CS objective? Quite often our teachers don't come in saying, hey, I want to mash these two together. It's more like, I've been assigned to cover this computer science learning objective, or I teach this and I'm looking for a way to like invigorate and refresh and to make this exciting using CS. So from that starting point, it's important to think of like any kind of tool considerations, like are you using Scratch, are you using some type of robot, are you determining to, are you doing something that's not tool related, but something that's more conceptual? Is it something that aligns and connects to a value proposition that you have or your society or community has? Or are you talking about some sort of modality as well? Like, are you doing a CS unplugged activity? All of those are considerations once you've selected the CS objective that helps you move into the next part. In the state of Virginia, we have two resources that we use. One of them is the Computer Science Standards of Learning, and then the other one is the framework, which explains all of the standards of learning and the key terms and essential elements and questions that need to be covered, as well as like a little bit of information about how far in depth to go with the information. So thinking of that essential knowledge as the important part, we use a targeting type of activity with teachers to be able to say, this is what I'm going to teach from the standard, because standards are often comprehensive, like they have a lot of different parts and moving pieces to them. So this is what I'm going to cover. And this is what I would like to cover, and then this is what I'm definitely not going to get to during this lesson. It narrowly constrains the activities of the lesson writing, and it makes it so that it's very, very tightly designed. From there, moving from that essential knowledge into determining that type of integration. So once you decided what's the target core and what's the target CS, you need to think about what's the balance of those two, because it doesn't have to be co-equal in order for it to be integrated. And there's a lot of different approaches to doing that. It could be something that is a CS supporting the core. So a larger portion of the lesson might be the core curriculum. And then CS is used to kind of to elevate and lift up that idea. And it could be the other way around too. Core is used more of a lens, and the major activity is more CS focused. And then, of course, you have what was talked about earlier today, a more thematic approach, where you're looking at two different things and thinking about how they connect together in kind of a conceptual understanding. And a good example of this would be talking about a computing system as being an ecosystem. Having a lot of interdependent parts that work together in order to make something happen. So that's an idea of that conceptual understanding. After you've got that figured out, identifying that scope of knowledge, what are you not going to cover? What are the things that you need as far as like vocab and questions to really define those chunks of knowledge, discrete knowledge that you're going to be covering in the lesson. And then we typically use what is used in the RTI type of experiences. It's called an essential standards chart, which covers what students know, what they're ready for, how does this connect to their learning, how does this connect to future learning and past learning opportunities. What does proficiency look like? And that's so that you can create an assessment around it that lets you know as a teacher what students have learned from the lesson, and then how are you going to do that assessment, and then how do students make meaning from that content? And that provides a wide tapestry of like their background, experience, and knowledge, their cultural, what they bring culturally, and what you're and to the lesson, so that you're thinking of that broad, like who are my students and how do I best serve them? At that point, finally, then you're ready to go on to lesson planning. So the main idea then with that is that all of these things fit in and create the information needed in order to create your lesson plan. So this is essentially what we use and what we're exploring at this time around intentional computer science integration. And feel free to reach out to me. My email is at the bottom if you'd like to have further discussions. And yeah.
Welcome back, everyone. It is lovely to see you and to see your thoughts on the Jamboard. So a few people have been putting their takeaways onto the Jamboard, and I invite everyone to please just take a minute and put one thing you learned, one resource you got, one question you still have, stick it on the Jamboard so that other people can benefit from it. I just want to give us a tiny little bit of time for reflection. And I want to ask if there's a volunteer who would share one of those out loud. What are you thinking right now? What did you learn, or what do you wonder? Go ahead, Mike.
I'll bring back something from the group that I didn't think of and I learned that I appreciated. We may get the best commitment from teachers of integrating computer science into other subjects, not just any old subject, but the ones that they consider core, that they're being pressured by their admins to still cover, even when other things get dropped, and that they know they're going to be assessed on. So the ones that came up in that category were English language arts and math.
Anything to share from the culturally responsive design group? No, Leslie was in there, and Elizabeth, and
yeah, I think we came to the conclusion, I mean, as curriculum developers, it's almost impossible to make the curriculum culturally responsive. What we need to do is provide opportunities for the teachers and resources and training, maybe to show them how to teach in a culturally responsive way, more so than at the curriculum level. It's more in the classroom. So I think that was our takeaway, if I'm saying that right.
there you go. Thanks, Leslie. Anything from critical algorithmic literacy?
We talked a lot about how this is kind of a foundation of why we should include, this is a bigger conversation than just getting a more diverse group of people in computer science careers, right? This is about understanding that there is bias in algorithms and the world is full of this. And so I suppose there were conversations about that. There were some books that were recommended by some people that I added on a post sticky there, and some great conversations. Scott was sharing a bit about his work with some young students and how even with those, say, 3rd and 4th graders, how that can be helpful. Anything anyone else wants to add to that little summary, please feel free to.
I'll just add what I put in the Jamboard, which is, from a media literacy perspective. If you look at media literacy, they talk about multi-literacies, expanding, what students analyze and create. And so traditionally media literacy says, well, I need to look at, movies and TV. And now I just think, by adding algorithms within another medium, then you're expanding what literacy means. And then we're also avoiding, one of the things you always strive to do is not, pile on another new thing, right, for teachers and admin. So maybe if we can integrate it to existing kind of literacy efforts, then maybe that will be useful.
Okay. I'm going to ask people, what'd you learn? What did you talk about? What did you think about? The next page in the Jamboard is available for you to post your takeaways. And I've got a little list of some people down here who have been participating. I want to hear from elementary first. Loads of people in elementary. Yes, go ahead and put your takeaways in there. And who was in there? Alba. Alba, would you like to share with us what you talked about in elementary? Or something you thought about?
Sure. We kind of shared that it doesn't matter where you are located in this country, that there's one commonality in elementary school, and that is that our elementary school teachers have so much to teach, and asking them to take on another subject to teach is a little tough. So I think that's why integration into other subject areas is super important. How exactly that's going to look like, I think, is going to vary from district to district and student population. And we also talked about when would be the most appropriate time developmentally to introduce technology at an elementary school student.
Well, thank you. The next room was design thinking. Who have I got from there? William, would you like to share some of your thoughts? Go ahead.
Yeah. First of all, I had a great conversation about design thinking because I didn't really know like what it was. So I kind of like went in blind. But it's from what I gathered, it's all about like the pre-work and looking at your pre-work like a survey from your users' perspective, trying to figure out what problems they may have, but trying not to stay on the surface problems, but to get deeper. So like asking a question and maybe rephrasing that question to like dig a little deeper. And then there's some resources. I think Stanford D School, and another one was IDEO. Are great resources that I learned that I'll look into a little bit later.
Great. Thank you so much, William. Our next breakout room was AP and high school. Ryan, do you have any thoughts on that?
I have a lot.
Excellent.
But I think some of the things we were talking about was kind of the attention span of students and how the pandemic has affected it. We had some anecdotal evidence that, some people preferred text, some people preferred videos. I personally preferred text, because it was just faster. And then we also talked a little bit about like kind of bite-sizing these projects versus making them more open-ended and kind of trying to find the balance between that. It's a struggle. We weren't able to come to a solid conclusion, but it was more of a discussion that we had and presenting the different perspectives that we had on it. So yeah, that was our AP and HS discussion.
Well, thank you everyone for sticking with it this long. This has been awesome. I'm going to get some feedback from everything, but first I want to hear from William. What was the end of your sentence?
I was saying that I was interviewing this AI pioneer from like the 70s, I believe. And one of the last questions that we had got to was like, how young should we start like introducing this to kids? And he had told me like fifth grade. And I was like, oh, because like I was like, oh, well, fifth grade in San Francisco, like we're like doing Scratch and maybe some make code or something like that. But he just really kicked it up a notch. And I was like, wow. And I can find his information if you guys will like it. It's just some interviews, questions I asked them. Okay, I'll look for it.
Cool. Thank you, William. Anything else from the AI breakout room that you want to share? It was a big room.
Well, we were talking a little bit about AI in general, but we kind of veer like teaching AI a little bit of how we should be teaching it, but a lot of it was just dealing with the sort of fallout of the AI innovations that have come out recently and how the educational community as a whole is dealing with them, and really thinking about how we're sort of talking to educators and supporting other educators in just managing these new technologies that they're having to deal with in the classroom. But we were, we had some nice discussions, because it was like there's so many different points of view, and we're still in the middle of it. So we definitely had some like not complete agreement on what the impacts might be, or what we could see. So it was good. I wish we had some more time to dig into it, but it was a fun discussion.
Let me hear from cybersecurity.
All right, I'll jump in. So we started the discussion off with the question kind of big about why cybersecurity isn't more taught, given that so many cybersecurity skills are so important for not only students, but also teachers, staff members, and parents. This seems to be a growing area of need and concern. And we also really got in depth into the idea of privacy and how trends point to privacy being less of a value to younger generations who are constantly sharing information about themselves. So we all had concerns about that, and we're brainstorming some ways to try and get more buy-in from students for the need to seriously think about maintaining their privacy and security, and maybe connecting not only to like the idea of other people being able to find out information about them, but that they could compromise themselves financially and face some negative impacts in terms of the money, not just the information. And then, yeah, we're also talking a lot about the kind of difference between technical cybersecurity for the purposes of entering a cybersecurity field, which is really important, but also is not the same thing as what I think we were most interested in, which is just general cybersecurity literacy. And along with that, like digital citizenship, digital literacy.
Great. I'm glad you got into that topic. That's one of the things I think is still fuzzy in the field, and I'm glad you're working on it. Let's hear from the professional growth room. Go ahead, Justine.
Sure. One thing that our group talked about and emphasized was like the power of still making sure that we're connected with the classroom and talking to teachers as well as students, because at the end of the day, we are creating these materials to serve our students, right? So it's important to also hear from them. I know Ryan is a recent grad, and that was super helpful to hear from him in the high school breakout room, things like that. So it's just making sure that we stay connected so that we can provide, the best resources for our teachers and our students.
I want to thank you again for being here and giving your time. And I want to give you a few minutes for some final reflection. I know this is a lot. There were so many ideas that were put forth both by, our lightning talk, 6 lightning talks, and our opening remarks by Patrick from Codio, and all of the breakout rooms we've had. So I want to invite you to reflect on how are you going to act upon the stuff you've learned today? What are you going to do someday? A lofty goal that you hope to achieve and have a dream and everything. But also, what are you going to do Monday? What can you act upon immediately? What can you do right away to get yourself a little bit of the way towards your someday goal? Go ahead, Elizabeth.
Okay, so I think there are a lot of great conversations, but one thing that I felt was really actionable was really intentionally doing more co-design with classroom teachers of the curriculum that we're doing in conjunction with the PD, just because I think that, well, actually, I don't have to say why. Everybody knows why. We should be co-designing with teachers. So that's my biggest sort of, yeah, I really need to be doing more of this.
Someday. Seems so far away that I can't really tell you what I would do today. But Monday, I think before Monday, actually, I think after we get done with this session, I've been just writing down some of these resources, some of these websites like the Conmigo and the Teachers Lead Tech. And one of my colleagues mentioned a series called Black Mirror that's on Netflix that I think I'll check out. So yeah, it was worth hanging out today. I appreciate it.
Nice. Thanks, Marco. Who's put a sticky on just now? Tell us about it.
But yeah, I just put on a sticky for the cybersecurity thing. So basically, I was telling my breakout room that I was part of a program in high school. It's called Voice State, where we essentially simulate like the government of the state that we're in, and with a bunch of like high school kids. And what I found was that like even though we were simulating like the government, we didn't have it wasn't a very good representation because we didn't consider it was like basically representing politics in a vacuum, which we all know politics does not work in a vacuum. There's a bunch of other interests at play, including like selfish interests from corporations and whatnot. And there's a whole economic side of these things that isn't really represented well. And the way that we can really teach kids about like the importance of like cybersecurity, I think, is by having them lose something, right? Because of their negligence or like from a data breach. And the best way to do that is by creating a whole separate like set of information that isn't actually their information, but like creating like a simulated environment where they have the potential to lose these things due to negligence. And I think that might be a really powerful way of teaching cybersecurity and general technical literacy because it gives students a sandbox to kind of mess around with these things. But that's a really big thing I'm proposing, so I
I
understand
love that.
this
You
is a
got a
very
lot of
someday
nods
goal.
here. You got a lot of developers now thinking about that. Oh, Ruda, you have one?
I guess so. I think I was so in the flow of so many of these conversations that at the moment I don't really remember what we talked about. But I took a lot of notes, so I need to, I think not Monday, but Wednesday is to go over all of these notes and kind of summarize. And I think in the breakout rooms that I was about culturally responsive curriculum, AI. I think just doing a lot of Mondays to get to some days, just keep diving into these resources and see what I need to follow through and dive deeper. I think that's the main.
Who's got 2 specific CS integration activity ideas?
That's me. That's me.
Go for it.
Breakout round number 1 that I was in was really interesting for me, and I got some ideas that I want to chase down. So some of the participants here posted things that they or their teams have worked on that bring CS into a subject area. I'm a little dispirited to hear that in some places you sort of need to have an entire course, an entire scope and sequence that's integrated CS with a subject. I and my team are not in position to do that for teachers, but if there's a nice nugget, a nice activity that really hits, that's something I want to add to our repertoire. So I'm going to follow a couple of those.
Great. Who's helping educators and students imagine an internet and tech world that serves them? Saber, nice. Do you want to speak any more about that?
Well, I mean, I think what you just said, Emily, earlier is like a really important point. I think we can serve a tech industry that isn't great, or we can also help imagine a tech industry that is great. And that includes the internet. I think I heard some strains of sort of like blaming our students for how they behave on the internet. I just think that's like a little scary to do because it's a world we set up and we put the rules, and often we have abandoned a lot of oversight over the tech world and the internet. And then to say, well, students don't care, that just feels like really dangerous. So I think part of a good tech education requires them to know that tech and the internet and those things are very like able to be supervised, democratically controlled. You can talk about breaking up Google if it has a monopoly over ads on the internet. A fundamental question about how we run our society that we've just sort of abandoned to just a few tech executives. So I don't know how we get there, but I think imagining things like, there are some ways like imagining writing into the amendments protections that protect your cell phone, which is kind of sometimes in the gray area of search and seizure. These are really important things. I think almost as important as any sort of tech thing that we teach is that it's a system of power and you are choosing to participate, or maybe that choice has been taken away from you, but reflecting some choice is really important. And I think I always struggle with that, is everything I tell them can also reinforce it. So I have to often make fun of computer science very aggressively to just get them to know that this is a dumb system sometimes. It's not a great system for you or for me. And all that fanboying around Python or JavaScript is, fanboying about different ways of saying the same thing. And you have to be really careful about those kinds of things, I think, to kind of have a student-centric classroom. But anyway, I think you all get that. So I just wanted to kind of catch Emily saying that, and I harp on it a little bit more.
Yeah, I think some of us in this room were born before the internet, and we have a certain perspective of like pre-internet and how we've seen it evolve, and that we can be critical of it because it's, we saw it evolve in not necessarily the way we expected. But so many of our students were born just knowing that the internet is a part of daily life, and to some extent that makes them feel like it's always been there, that's the way it should be, we can't affect it. And so I think that we need to explicitly give them back that power, right? Not just assume that we think they have it already, because we do. Right? So I'm really interested. I cannot wait for the majority of curriculum developers to eventually be post-internet babies, right? It's going to be very cool and different, and it's something that I hope that I am obsoleted out of. Cool. So we have 3 minutes left. I want to leave it open for final thoughts or feedback on this particular experience. So I have a slide here on the Jamboard number 10, where I am happy to take feedback and ideas for how we can make future summits like this better. Please feel free to keep contributing to the Someday Monday, and add in here my personal idea for how to make next one better is to have a poster session that like anyone could submit their kind of one slide poster for a takeaway or an idea or a bunch of links. And then we wouldn't have to take up all the time for everyone individually talking, but maybe that could be a cool collection of resources. Ooh, inviting some students for their perspective. Lovely idea. Please. Yes, more and more. And is there anyone who wants to volunteer to host the next one? Patrick, how hard was it to host this one?
It was not hard at all. I remember when Emily asked, I'm like, oh no, I've got this thing. And we were like at this huge business thing last week, and it's super crazy right now. And I'm totally fine. Like, it's really not that bad. I'd be happy to tell everyone what I had to do. It's not much, mostly just learning Eventbrite, but like, it's really easy.
I am so happy to have had you here, and I hope you all have something to take away. And at this point, I'm going to let you go. It's